Good morning, Cappuccino. It is Friday, May 15th. Sorry, it's been kind of a wacky week, but here is our third warm-up of the week. This is optional for seniors, but seniors, this is good adulting information about banking. So if you want to do it, I'll give you extra credit. Juniors, this is required for you. And we are going to be using the new formulas that you got yesterday in the latest assignment. So first of all, we're talking about some different types of currency here. Vise invests 500 million LAK, which is Lao Kip. So in Laos, this is the currency. It's called Kip. And Vise is investing 500 million Kip. Sounds like a lot. I have no idea if it is. It would be kind of interesting to look that up. In a bank that pays 3.2% interest compounded annually, calculate how much Vise has in the bank after 8 years. All right, so we have the formulas from the worksheets yesterday, and you can put those into your notebook, or you can just look at those sheets. Either way, it's fine. Next year, HL students, you're going to be getting a new formula packet, and this is the new formula packet. See, it says SL and HL. And here is the formula. So this is the formula that we got in our worksheet yesterday. So FV, future value, is equal to present value times 1 plus the interest rate divided by 100 times K, which is the number of compounding periods per year, all raised to the K times N, where N is the number of years. Okay, so we can use that. We can use this general formula for all of these compounding interest problems. So the reason why there's 100 here is because when you put in the interest rate as a percent, you need to divide it by 100 to make it into a decimal. So if you put in R as a decimal, so for example, if you would put this in as 0.032%, then you would not divide by 100. Okay, so that's why the 100 is in there. It's to take your percentage and change it to a decimal. All right, so you're going to go ahead and do that. First 5 people who turned it in, you'll get 5 points extra credit. Notice the second problem here is in euros. All right, so we're being international. It's good to be realized that different countries use different types of currency. The euro is very similar to the dollar, but I am kind of interested. How many kip to a dollar? How much money does Vise have in U.S. currency? Very interesting. All right. So let's go over the previous warm-up, which was from Wednesday. So Sheldon has this experiment. He's adding 60 milliliters and then 50 milliliters, and we know it's a geometric sequence. So we need to find R. So times by R. So 60 times R is equal to 50. Divide both sides by 60, and you get R is equal to 50 over 60, which simplifies to 5/6. Okay, so there's my R. Find the amount added to the fifth solution. Okay, so I've got a geometric sequence, and the fifth solution, that's going to be a term. So that's going to be a term, the nth term of geometric sequence. So this is the new formula packet. Let me go back to the old formula packet, because that's what you have. All right, so it's going to be this formula right here. So U sub n, because I just want a term, I want the fifth term, is equal to U sub 1 times R to the n minus 1. Okay, so U sub 5, because we want the fifth one, is going to be equal to the first one. The first term is 60. And R, I figured out, is 5/6. Raised to the n, well, this is the fifth solution, so that would be 5 minus 1. Right, and then if you put that into your handy-dandy calculator, you get 28.9 milliliters. If you're using 3 significant figures. There it is. Okay, find which solution will be the first to have less than 10 milliliters added. Which solution will have less than 10 millimeters added? So I'm going to use the same formula again, and the amount, the term, is going to be less than 10. So I want this number to be less than 10. I'm just going to go ahead and make it be 10 for right now. So I'm going to make that 10 is equal to 60 times R to the n minus 1. And I don't know which term it is. Okay, so I'm just going to figure out where does 10 arrive, and then I'll figure out from there where I'm going to have less than 10. Because if I can figure out where 10 is, then it's going to be the term after that, right? Because the terms are getting smaller. All right, I could have set it up as an inequality, but I was having a hard time trying to figure out, oh, which way does it go? 10 is less than this, or 10 is greater. So I'm just going to solve it with an equal sign, and then I'll figure out the answer at the end. All right, so let's solve this. I'm going to divide both sides by 60. So I'm going to get 10 over 60, which reduces to 1/6. Okay, 10 divided by 60 is 1/6, is equal to 5/6 to the n minus 1. Now I have this issue. I've got my variable is in my exponent. So to get that down, I can use logarithm. So I'm going to take the log of both sides. So I'm going to take the log of 1/6 and the log of 5/6 to the n minus 1. Now I can use my power rule, and I can bring the n minus 1 in front. So I've got log of 1/6 is equal to n minus 1 times log of 5/6. Okay, I'm trying to get n by itself, so let's get rid of the log. So I'm going to divide both sides by log of 5/6. I'm running out of room here, so I'm going to bring it over to this side over here. So let me copy it over. Log of 1/6 is equal to n minus 1 times log of 5/6. So I'm going to divide both sides by log of 5/6. So I get log of 1/6 over log of 5/6 is equal to n minus 1. And then to get n by itself, I need to add 1. So log of 1/6 divided by log of 5/6 plus 1 is going to give me my n. Okay, so then I'm just going to put that into my calculator. And if I put that into my calculator, I get n is equal to 10.8. Okay, there's no such thing as the 10.8th term. That doesn't exist. So, because there's either the first term, second term, third term, fourth term, fifth term, sixth term, etc. So if it equals 10 milliliters at term 10.8, which doesn't exist, it's going to be less than that at the term, the whole number after that. So it's going to be the 11th solution. Okay, right? Because he's making a bunch of, chemistry experiments. There's the first experiment, the second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. This is an example of discrete data. You can't have a solution in between the 10th and the 11th experiment. You can't have that. It's either the 10th experiment or the 11th experiment. So it's going to be the 11th is going to be our answer. All right, that was the hard one. All right, next one. Given Sheldon has 400 milliliters of the chemical, prove that he will have enough however many test solutions he has included in this experiment. Okay, so notice R is less than 1. R is 5/6. So that means that if we do a gazillion experiments, we will have a geometric series that it's infinite, but it's going to converge because R is less than 1. So we are going to use our formula for an infinite geometric sequence. Okay, we're making an infinite number of solutions. Since R is less than 1, we can use this formula. So we're going to use the formula. The sum of the sequence is equal to the first term divided by 1 minus the common ratio. Okay, so the first term is 60. And then 1 minus 5/6, because the common ratio is 5/6. So we get 60 over 1 minus 5/6. Well, 1 is the same as 6/6, so that would be 1/6. And to divide by a fraction is the same as to multiply by the reciprocal, which would be 6, which gives us 360. So that's how many milliliters. If we did an infinite number of experiments, we would only need 360 milliliters, and 360 is less than 400, so we're good. We don't need any more solution. No matter how many experiments he wants to run, he's going to be fine. Okay, so for today, For my juniors, there is going to be a math space assignment, and it's using this formula. Okay, so this is the same formula that is in your that worksheet from yesterday. Here it is, if you want me to zoom in on it. Okay, want to use that. Use that for your math space today. That's going to help you out. And seniors, if you want to do it, I'll give you extra credit. Okay, again, it's good adulting stuff. It's all about banking. Good stuff to know. All right, take care. We do have office hours today at 10:20. 10:20. If nobody shows up by 11, I'm signing off. All right, so see you there or not, and have a good weekend. Bye-bye.